Okay, I'm going to get things started here because I don't want to delay even as people are still coming in, since I want Julio to have as much time as possible. I'm excited to welcome everyone to today's Wednesday at NICO seminar for multiple reasons. I think the topic is incredibly timely given the AI revolution that we still have in full swing, and also the recent drop in support and funding for science. I think understanding breakthroughs and creativity is more important than ever. But I'm also extremely pleased to welcome Julio here because for those of you that don't know, NICO, the Northwestern Institute for Complex Systems, would not exist without Julio. He was the architect of NICO, and he founded it back in 2004, and had an, I would say, incredible amount of vision to put aside traditional silos in different academic disciplines and establish an institute where people could collaborate across those boundaries, especially at that time. But that is par for the course for Julio. I think he's been doing this throughout his career, including from his early work on chaotic mixing in fluids, combining chaos theory with fluid dynamics, and on through granular mechanics, but also in the art. Those of you who don't know Julio might not know that he is also an accomplished artist, visual artist, and he's been doing that throughout his career as well. And I think maybe that's what led to his creation of the whole brain engineering program here at Northwestern as Dean of the School of Engineering, which combined the left and right brains, creativity, and analytic capacity. So Julio's been accomplished both in research and in his leadership at the university. And I think beyond NICO, he also founded the Siegel Design Institute, founded the Farley Center for Entrepreneurship and Innovation, established collaborations across a lot of different schools. I could go on for a long time. Let me just mention the many honors. He's a member of the National Academy of Sciences, National Academy of Engineering, American Academy of Arts and Sciences, a Guggenheim Fellow, Fluid Dynamics Prize from the American Physical Society, G.I. Taylor, recently G.I. Taylor Medal from the Society of Engineering Sciences. But he's also not abandoned, despite being or in addition to being a great researcher, he's also continued with his artistic endeavors. If you guys don't know about his book, The Nexus, Augmented Thinking for a Complex World, that came out a few years ago. It's a beautiful book just to page through. I highly recommend it, but also explores this amazing intersection of art, technology, and science. So I'll stop there, though I could go on for much longer. So again, I'm excited to hear Julio's thoughts on scientific breakthroughs, but also just really happy to welcome him back to NICO. So please join me in welcoming him.
Thank you. Thank you so much. Thank you. Thank you. So yeah, I'm really pleased to be here for several reasons. I think this is the third time that I have been here. I was able to find a video maybe 2 years ago, maybe 3 years ago, where I introduced the book that I was writing. But this time, and this is the book, okay? And this talk will dovetail with the book because there is the upper part of the title, Augmented Thinking for a Complex World, is what we'll be talking about here. But is the second part is the new convergence of art, technology, and science. That's about augmented thinking, okay? Now, that book I wrote with Bruce Mao, but the whole talk in here will be an outline of ideas of another book that I'm doing, and the book is with Daniel Diermeyer. And Daniel and I were the ones who founded NICO, okay? So I'm pleased because of that, okay? Now, I have to explain the clocks and clouds. comes from Karl Popper, Austrian philosopher. Clocks may be complicated, but they can be solved. Clouds are amorphous, shapeless. That's the distinction. And the world that we are going to describe in here, this is the outline. Okay, so I will go and describe the Newtonian worldview, which is probably much more amazing than people think. I will describe what were the cracks in the framework. Then, as a sort of bridge, I will get into AI because you will see why. Then I will talk in terms of, this could be advice to individuals or advice to organizations. So I will talk in terms of organizations. And then I will reframe things. And then I will close it with how to act in this cloud world. Now, the Newtonian worldview was amazing. Clear connections between cause and effect, and determinism, perfect determinism. And the world now is very different. The world now is a world in which, I don't know if this shows in here, is probabilistic rather than deterministic, requires comfort with emergence, and the shift requires different cognitive frameworks, and this is what we'll be talking about in here. So we are living now in a cloud world rather than a clock world. Now, the problems arise when you are using clock thinking to solve cloud problems. And is our thinking prepared? The answer is really no. Why not? And it's because of the amazing success of the Newtonian worldview. The Newtonian worldview has given us amazing things, and I will explain what those things are. It's much more in transforming the world than we talk about AI transforming the world. The Newtonian worldview changed everything, and I will tell you why. But if you apply Newtonian thinking in the wrong way, you get big problems. And every revolution goes too far, okay? And in some cases, the Newtonian thinking went too far. And then you have problems. You can write books about each of them. Soviet central planning could be one. I like the launching of the 747 Boeing, okay? The war on cancer. All of those were misapplications of designing a city in one shot, like Brasilia. All of these were misapplications of Newtonian thinking. So I will place the Newtonian revolution on a broad canvas, and this is a broad canvas, and you cannot read this, okay? But time goes from left to right, and science is on the top, technology, waves of innovation, even management is in there. And more than that, at some point is when algorithms reveal solutions, and then the advent of AI. So I'm going to start there. Teeny little thing, but I'm going to magnify. That's where Newton's Principia appeared. And by the way, Newton was really lucky, okay? Because a lot of the groundwork battling Aristotelian views was done by Galileo. And by the way, many of you may know this, the year that Galileo died, Newton was born, okay? But I'm going to start earlier, and this is part of the thinking before Newton appeared. And we are talking about this book, Thomas Hobbes' Leviathan. This is about 35 years before Principia, okay? Why I'm mentioning this? Because Thomas Hobbes was probably the foremost philosopher in England, and he was in awe of Galileo's ideas, who was regarded as the foremost natural philosopher of the time, and visited Galileo when Galileo was under house arrest because he kind of crossed the line for the second time with the church. So he was there, and Hobbes visited him. What Hobbes was fascinated by was the idea, the first law of Newton, really, Newton's law, is Galileo's. If no forces are acting on a body, the body will continue moving or will stay where put, okay? So Hobbes drew an analogy between what bodies will do if the forces were in equilibrium, acting on them, with what kind of forces will have to act on individuals to produce the best possible society. We are talking about very early here, okay? And based on what was 3 laws, the first one was the Galileo's law of inertia. Based on these 3 laws, Thomas Hobbes deduced the first form of government that would satisfy people not living solitary lives, nasty, brute, short lives. Principia appeared in one shot 35 years after this, and Principia is full of theorems and lemmas, but as you know, there is not a single equation in Principia, okay? Not one. It's all geometry. And the idea was that somehow Newton thought that couching this in terms of calculus would have been harder than understanding geometric arguments. By the way, everybody talks about Principia. If you want to find the calculus written by Newton, there is one paper. There are 3 by Leibniz, okay? But then Newton emerged, okay? Not in one shot, and I'm going to explain. And what we got of Newton was the public persona of Newton. He had a weird private persona. He believed in alchemy. He believed in the origin of the world based on biblical sculptures, a whole bunch of things. The public persona of Newton was Principia and optics, okay? But based on that, there are depictions like William Blake on the right as the powerful mathematician governing the world, or even the epitaph in here. The God said, let Newton be, and all was light. This was a proposed epitaph for the Westminster Abbey by Pope, okay, Alexander Pope. And there's a hidden side of Newton, and there are many people now, starting with Feynman and people, Glasgow, that have revealed how Newton kind of massaged numbers, but what he did was amazing, but it was less amazing than the almost mythical status that was conferred in his lifetime. And Newtonian view changed a lot of things. To start with, it changed the idea of God. If there is perfect determinism and everything is set, what's a role for God? Everything, God could just walk out and the world will go, okay? Affected philosophy, economics, politics and government, the separation of powers. By the way, all the founding fathers of the US were all Newtonians. The Constitution of the US is a Newtonian document, equilibrium. Now it's being tested at equilibrium, but it's an equilibrium. And organizations. The idea of the modern organizations with outcomes is a Newtonian idea. And I will focus on that a little bit, on trying to describe the world that we saw. But Newton was helped, big time. And was helped by not Lagrange and Laplace that I mentioned, but by the formidable Madame de Châtelet, who was one of the ones who helped Newton. Who was her? She was the mistress of Rousseau, sorry, not Rousseau, Voltaire. Voltaire was famous now philosopher in France. He had been in prison, put in the Bastille, spent a year in there in solitary confinement, and then, believe it or not, he persuaded the French government that as an alternative punishment, could they send him to England, okay? And he went to England, he fell in love with Newton, wrote several articles about Newton, and Madame de Châtelet is the one who translated Principia into French. It's still the translation that is in France. Not only that, she added kinetic energy that Newton didn't have. So the combination of these two, by the way, Voltaire, not happy with promoting Newton, denigrated poor Leibniz. He wrote a paper about someone who's very simplistic in the thinking, and one of the Pangloss character in Candide is after Leibniz. Poor Leibniz, he was attacked in several fronts, but Voltaire is the one. The idea of the apple falling on Newton's head, Voltaire, okay? So the perfecting the Newtonian picture, wow, you have these two people, analytical thinking reign supreme. By that I mean not contaminating the thinking with pictures. Lagrange said this book shall contain no pictures. But then there were a little bit of problems. The problem was that out of the perfection of the Newtonian universe, when people wouldn't believe the perturbations in Uranus that was not behaving exactly as predicted, this is more complicated, and there's a whole book written by John Barrow Green on this. People back calculated the perturbations on Uranus due to an unknown planet, and then unknown planet became Neptune. And so the belief on the Newtonian framework was absolute, okay? But the problem was that you could solve only two bodies. The three-body problem was still pending. So there was big story about this, big prize, jury that involved mathematicians like Weierstrass, and the one who won, but was not regarded a big achievement at the time, was Poincaré, who basically discovered the essence of chaos. But the belief in precision still persisted, and almost at the same time as Poincaré was tackling the three-body problem, Albert Michelson, south of here in Chicago, said, he's being quoted in here, Millikan is the one who was in the audience, the one of the electron charge, now persona non grata in Caltech, by the way, that he said discoveries over the next several decades will be about getting the 6 decimal place correct on things. So this is, and not only happy with that, he cited several examples. And the last example was the discovery of a new planet by the observations of Le Verrier. So there were two people who competed for finding this planet, Le Verrier and John Couch-Adams, one in France, one in England. The French fellow announced his findings to observatory in Berlin, and that's the one who won. They found the planet within 30 seconds of where it was supposed to be. So the structure of the book is this. I will start with Principia. Then I will mention the awe-inspiring revolutions, and I will draw lessons from them. And I will start with the first revolution, which is really not regarded as a big revolution because the physics revolution sucks all the air, and the poor chemists who, by the way, discovered conservation of mass. There was methodological innovations in precision measurement, and I would call it the elements of the world. And if you have to summarize this in one, remember, they also had to battle alchemy, okay? So everybody thought that they knew some chemistry. After all, they were producing alloys, dyeing textiles. No one was dropping bodies from inclined planes, but they thought that they knew. So the chemists reserve some credit for this. And basically, the summary of this is that everything in the universe is made of these elements, and the combinations of these elements are much richer than the elements themselves. But these are the revolutions that I'll be talking about. And they are sort of ordered chronologically, except for evolution is in here, should be much further above, and I will explain why. And in all of them, I capture them in some, I didn't write this at the beginning, I went long, shorter, shorter, shorter. And so, for example, the power of the many is the way that I describe statistical mechanics. The death of the absolute, the science of the tragic is game theory and so on. And in there you have some descriptions. And here is a little bit more of the descriptions, but for all of them, I had something like what you have in here. So, for example, for the dawn of the discrete, if you have to extract the essence, it show that all computable processes can be reduced to simple operations of symbols, okay? Or created a framework where physical systems can be understood as information processors. So for all of them, I did something like this and produced the list that you see there. And there's a list, okay? And I put at the beginning, at the top, Newton's Principia, Poincaré, three-body problem on the right. So why the colors? The colors are because all of those emerge as consequence of some thing that had to be fixed in the Newtonian framework. Sometimes something that didn't look that big, okay, like black body radiation for emergence of quantum. And all of this originated outside physics. Now, I put game theory there because game theory is mathematical. After all, von Neumann is the one who came up with this. And it's mathematical like all the things above, but deals with people and life like all the things below, okay? And again, just to put von Neumann, in computations, algorithms, almost at the same time of Watson and Crick, they were these self-replicating algorithms. So you can argue that all of those are people and life. And they were crisscrossings. They were people traversing areas. Probably the one who was in most areas, I would say, is von Neumann. But there were conversations in between Gibbs and Maxwell and Boltzmann. And von Neumann was in quantum, but in game theory, and we wouldn't have computers without him, so he was in here, everywhere. And there were some crisscrossing here, but the number of people in here augmented exponentially. In there were less people. And one thing that was amazing is that this fellow, Darwin corresponded, he has, his archive is 15,000 letters. He talked with everybody, but did not talk with anybody above. Okay? No one above. But then I discovered this. Boltzmann was in love with Darwin. It's amazing, but in his writings, and this is one of the phrases in there, what would the century be known for? I answered without qualms that it will be named the century of the mechanical view of nature of Darwin. So he saw some relationship between statistical mechanics and evolution. And the question is, if Darwin and Boltzmann could see these connections, are there more connections that if you start putting them all in, extract the essence, something will result out of that? So an emergent view, if you want. And the emergent view, as I said, I will phrase it in terms of organizations, because this is the organizations in terms of the Newtonian view. Hierarchical organizations with clear chains of commands and defined roles, standardized procedures and protocols, performance measures, quantifiable metrics. If you want, all Northwestern is like this, okay? They believe that outcomes can be predicted and managed with the right information and controls. So let's put all of them together. What does emerge? And what emerges is, this is what I extracted. The organization of the future is one that embraces uncertainty at the micro level while maintaining a strategic direction at the macro level, one that accepts, synthesizes, and draws values from contradictory viewpoints, derives benefits from multiple perspectives, has the ability to evolve ideas and create conditions for emergent creativity and innovation. Pretty good. And you can see that almost every segment of that paragraph came from one of the revolutions. The question is, there are more revolutions that I could add: complexity and chaos, network science, and what happens if you add these things This is the summary of them. And in here you can use AI if you want to, but the organization of tomorrow functions as the biological rather than engineered systems, modular, resistant, and interconnected. It harnesses contradictory viewpoints, distributes decision-making, and establishes boundary conditions rather than rigid processes. They are all great. I mean, you will be happy to work in a place that has this as the operating role, okay? Now we reach the tools. The Newtonian viewpoint wouldn't have happened, first without calculus, and then all operation research serves Newtonian thinking. A lot of statistics, although part of statistics now serves AI, but what is the machinery for this post-Newtonian thinking? I put complex systems, network science, AI, probably more, but let me focus on AI for a second. And I'm not going to go in detail about this, what AI can do, but demonstrating an intelligence-like capability can emerge from statistical pattern recognition. You can read it, and this is what AI can do. But the important thing is that at some point in that big table, we reach algorithms where solutions are revealed, and then we reach the advent of AI. And AI does many things well, and I have given talks where I think AI will do wonderful things for people like here, will make you better, and it will make dumber people who rely on AI just for thinking, okay? Can do all of these things well, okay? And can be a bridge between domains, which is relevant to that nexus idea, a creativity emerging from cross-domain synergy. But let me tell you something about creativity and AI. So let's start with the fact that AI cannot invent the future, can rely on everything that has been done in the past, and can access everything that is there within a given domain. The domain could be, I don't know, condensed matter physics, for example. So AI can answer questions. Tell me about this. Or tell me the connection between these two things. And maybe there's some new idea in there. Or find the connections between this and this and this and that. Or fill holes. If you know that there's a hole in the domain, find it. Now, the holes can be very hard to fill. For example, there are holes in math, and there are outstanding problems that the Clay Institute will give you a lot of money if you solve them. Good luck solving those, okay? But you can fill holes. And some ideas are what I will call breakthroughs. A breakthrough is something that emerges within the domain, is big enough that enlarges the domain. In fact, I call it breakthrough because you can imagine that expands the boundaries of the domain, breaks through the boundaries of the domain, and eventually enlarges that, okay? But there is something above that, and because as good as these things are, all ideas stay within the domain, because that was the material that you used to produce anything. They stay within the domain. So these are breakthroughs. What's about a breakthrough is a break with. A break with something that is outside the domain, completely outside the domain, and all scientific revolutions, by the way, they were break with, okay? So the essence of break with is leaving the domain. And the example that sometimes I use is flatland. It's a mythical world in 2 dimensions, and these people are visited by a sphere, but they cannot conceive 3D because they're acting on 2D. So the whole point in here is that break with requires stepping outside an inherited framework. And a system, there's probably much more in here, that's why I mentioned Gödel in there, cannot generate its own transcendence, okay? So for example, I feed everything in Western art prior to 1900 to AI, and could AI produce cubism? The answer is no, okay? In the same way that you could feed all the history of physics prior to 1900, and it will be very unlikely you can generate quantum mechanics or relativity, because every piece of training data contains implicit assumptions that you have to abandon to produce a new thing. So, which brings to this point, okay? Picasso said this in 1968, was prehistory for computer standards, but he had a point. Said computers are useless, they only answer questions. And let me give you one example on this. So origami has been with us for 500 years plus. Tensegrity has been since 1921. This fellow Carlis Johansson in Latvia, an sculptor, did an exhibit. They were all tensegrity sculptures. But now there are all of these things. This is work by my friend Glausio Paulino in Princeton. There are applications to a whole bunch of things. So you went from origami, classification of patterns, mathematicians becoming it. One thing leads to another one. You have origami engineering. And then you have applications to aerospace, architecture, robotics, material science, a whole bunch of things. And the question is, what possible questions could you have asked that generated this as the answer? The question could not have been, oh, I wonder if there are applications of math in origami. If you're asking that question, you already know kind of the answer, okay? So I think what has to happen now, and this is just one slide after I given talks more about this, is that there has to be a renaissance on the ability of asking questions, okay? Because you have to ask questions that unlock creative ideas, reframing questions that from specific domains to cross domains. And in my view, the human capacity for productive confusion becomes irreplaceable. The ability to be puzzled by things that everybody else takes for granted, okay? So we need to rescale the perspective a little bit. And in here I have more about what the Newtonian worldview produce. Economics, Adam Smith, Invisible Hand, markets finding equilibrium, that comes from Newtonian viewpoint. The laissez-faire, minimal government interference, things will equilibrate with proper controls, that's a Newtonian idea. We mentioned before separation of powers. James Madison, checks and balances, comes from there. So it's a whole bunch of things, okay? Including affecting, at the beginning, even theology, because of determinism, okay? So, but the Enlightenment, that was a consequence of Newtonian revolution, is when the idea of progress became reality, okay? To understand things was to advance. Before Newton, the Aristotelian viewpoint was that all knowledge resides on the ancients, okay? Knowledge was not seen as something cumulative. But with Enlightenment, that Enlightenment created the Industrial Revolution, useful knowledge became a mission, not a private pursuit, okay? The belief in progress created a new feedback loop that created more progress. And this is work that my friend and recent Nobel Prize in Economics, Joel Mokyr here, has done. Basically, Joel studied why the Enlightenment culture created the Industrial Revolution. And I don't ask me how people can calculate the GDP in the year 250, okay? But this is when James Watt appeared and the steam engine appeared, and this is how much people know how much the efficiency in the US increased, and the rest is history, because by about here, 1900, half of the US population work in agriculture, and now 2%, okay? And this owes up to the year 2000, but this is more recent, 224, and it keeps going up, okay? So why this happened is, according to Joel, is because two things happened. The people who knew things, the savants, the proto-scientists, people like Priestley, for example, or Darwin, actually, not Charles Darwin, the grandfather of Darwin, those people connected with the people who knew how to make things, like Wedgwood, if you're into porcelain, Wedgwood, to the point that became acceptable for Wedgwood to ask a question to Lavoisier. Before that, when those worlds connected, an explosion happened. It was connecting knowledge and practice, okay? A good example of this combination was the Lunar Society. It was called Lunar Society because they used to have the meetings during full moons so that they could work. This is before electricity, okay? They could work home safely. But this connected people who were real engineers with people who are proto-scientists. The word scientist had not been invented yet, okay? So knowledge becomes the engine for growth, okay? This is when knowledge becomes accumulated. By the way, journals started more or less at this point. Journals, it was not like people said, all scientists will agree, should publish things in journals. There is a nice book from a fellow in Harvard, a historian of science. Many people resisted journals a lot. The president of the Royal Society lost the job because he pushed for the creation of a journal, okay? But eventually journals were invented, knowledge was stored, a patent system was created, and the rest is history, okay? So knowledge and organizations become the engines of growth. And again, in here, I have what the organization means for me. So it's a big change, big change. But there's another big change. The big change is in here. Algorithms reveal solutions, and I have a whole bunch of things. The structure of DNA there, the creation of NSF, von Neumann theory of games in there, the Turing test, Claude Shannon, who, in terms of impact on the world to reputation, must be the highest of anybody that I have mentioned, okay? All appear in here. And amazing technologies were created here. Radar, for example, emerging there, Vannevar Bush. And why did they emerge in there? Is because we knew how things work. We knew the foundations. We knew the physics, the chemistry of things. And to the point that at some point, and this was in '59, Eugene Wigner, who was a colleague of von Neumann at the Institute for Advanced Studies, wrote this little paper on the unreasonable effectiveness of mathematics in physical sciences. He was amazed. So we could design things, we could predict things because we understood things. But now we can predict things without really knowing how the prediction came about, okay, with AI. So let me do a recap of the Newtonian, post-Newtonian world. This is probably the most important. We went from certainty to probability, determinism to emergence, from linear causality to complex feedback systems, human exceptionalism to continuity with nature. A way that I have to explain this, Northwestern is big in design, Segal Design Institute. There's something called human-centered design. You don't solve climate with human-centered thinking. You have to draw a bigger circle. So the bigger circle could be life-centered design. Okay, so, but this one comes from evolution, really. It's all one thing. So you have this evolution. So what is needed now is a way of seeing and acting that embraces complexity and the cloud nature of the world rather than resist it, okay? A view that teaches us to design for adaptability, nurture resilience, and see uncertainty as a source of creativity. A lot of what is needed there is in complexity. It's in there, and I put the things, there's much more in here that you could add. You could add your favorite things under the basket of complexity. But the truth is that complexity and everything that you can put in here They give you the tools, the language, the models, but not the mindset. Okay? You could be a genius in complexity and have screwed up solving those problems of the Nokia launch and the war on cancer and whatever. Okay? So it's complexity plus what else? And again, going back to the organization of the future, the organization of the future has to be able to do these things. And I highlight in here, embraces, maintain, draws, evolves, creates. Internalizing these verbs, okay? It's not simple. It's basically what you need to go to business school to kind of put this within your DNA, is the mindset, okay? You can have all the tools and not have this. So what you need more in here? And the need more, in my view, is, I go back in here, this is one part of the augmented thinking, and you can call it cloud thinking, okay? I don't have the outline of a course or sequence of things that you should do to embrace that thinking, but that's what is needed. So the augmented thinking embraces uncertainty as a feature, not a failure, adaptability and emergent order. For example, emergence is very, very hard for people who run organizations to accept, because letting things emerge bottom up is not part of the plan, okay? What they don't understand is that sometimes you don't need a plan. You need a vector, okay? You need a direction. That's leadership, in my view, is letting emergence become possible, okay? So the next revolution is not scientific, it's cognitive. So for 3 centuries, we live in a clockwork world that did amazing things, okay? More than what anybody can possibly imagine. One built on precision, prediction, control, and that mindset gave us extraordinary power. Today we inhabit a different kind of world, one of networks, interdependence, and emergence. Most of what matters, economies, organizations, societies, behave like a cloud, adaptive, evolving, alive. So science itself has been teaching us for more than a century, is what I extracted from those things, the key nuggets from each of the revolutions. Relativity killed the absolute, quantum mechanics put probability and duality at the center, evolution showed that imperfection drives progress, DNA showed the power of a 4-letter code, okay? And computation revealed that simple rules can create endless complexity, okay? AI extends the story, astonishing in its reach, yet bound by its frame. It can remix the known, but cannot yet break with the past, okay? That still belongs to human curiosity, okay? And those who ask questions and reframe what's possible. In a sea of sameness, there are many things coming out. You see videos all the time, they all look the same. In a sea of sameness, imagination is the most important thing ever, okay? So the organization of the future will embrace uncertainty at the micro level, holding clear direction at the macro level, drawing strength from contradiction, learning, and emergence. So we must stop thinking solely as clockmakers, perfecting mechanisms, and learn how to think like cloud watchers, seeing patterns as they form, fostering direction without rigidity, finding possibility in uncertainty. This is the art and the promise of thinking in a complex world or in the cloud. Okay, thank you.
Thanks so much, Julio. We have some time for questions, and I'll just ask people to please try to take the mic. We have 2 mics so that people online listening can also hear the questions. So I'll pass it around.
Thanks. Yeah, thank you for a truly fascinating talk. I'm curious if you could talk a little bit more about this idea of embracing uncertainty at the micro level, and maybe with some examples. It seems clear what not to do. Don't try to micromanage the micro level. But what does it mean in a positive sense to what should organizations be doing that would fit with this idea of embracing uncertainty at the micro level?
There are tons of courses on leadership, okay? But it cannot be encapsulated in some kind of recipe and algorithm, okay? Takes us long to absorb some of those things as learning some chapters in physics, okay? But that's why I'm saying it's a cognitive thing. The idea of surrounding yourself with people who augment your view, I would say, is a must. But the idea of creating, you shouldn't kind of bet the entire organization on emergence, okay? But if you don't make educated bets as to what the next thing could be, you are destined to be out of business, okay? So, but it's hard to encapsulate the idea in a few lines. Yeah.
Thank you so much. I was kind of suspicious about your explanation of Newtonianism and the post-Newtonianism change, because for me, I feel like Newtonianism kind of evolved as like a new Newtonianism rather than post-Newtonianism, where some of the sectors who holds the power of like this techno-feudalism is really using the power of that precision prediction and the database mindset into creating the like polarization of knowledge, and as you mentioned, limiting people's freedom and imagination and thinking from bottom up by creating systems that limits the knowledge. So I want to hear your linkage between that Newtonianism and post-Newtonianism and how should we evolve?
Let me kind of mention one thing. Some revolutions started with a clear lead. Darwin with evolution, quantum mechanics with a few people, Bohr, Schrödinger, Heisenberg, and Dirac, a lot of people. Statistical mechanics and thermodynamics didn't start with, it took longer, okay? But the truth is, if we didn't have that, we will still believe that nature is reversible. Newtonian is great, it's mechanics, but it took Boltzmann and people like that to show where irreversibility comes in the world, okay? So even if you believe all the things that Newtonian things did for organizations, precision, and so on and so forth, organizations like, I know, ITT in 1970, IBM in 1980, perfect organizations with lines of command and control, is still not enough to describe reality, because there's no irreversibility in the Newtonian picture. Now, if you want to really think and discuss something that will let everybody here go with different ideas, let me mention one thing. So I mentioned all of this. And I mentioned the patron saint of Newtonianism, and it should be more than Newton, okay? I mentioned Lagrange, Laplace, but there were a whole bunch of other people involved in there, okay? I mentioned these two people, and they had to battle Aristotle. So for example, Aristotle believed that if something was moving in space, it was because there was a force acting on it, and many, many things. And Galileo was the one who could kind of overthrow that idea. And then there are other people. By the way, this is an interesting one. Maxwell, to me, is as great as Einstein, really. But the year that Maxwell died, Einstein was born. Okay? So the question is, the patron saint of Newtonianism, let's say Newton, okay? Who is the patron saint of the things that follow? And everybody will have different ideas, combinations of people, okay? If you need to have a philosopher in the picture, I mean, I could go and ask everybody in this room, name a living philosopher now. I don't think any of you can name one, okay? They don't have the power that they had in the 1700s, 1800s. But if you go pre-Aristotelian, so you have the sequences, I know, Socrates, Plato, Aristotle, one was the teacher of the other one. Heraclitus, this is the fellow of, you can never step in the same river twice. His idea was the world is constant change. It's always evolving. It's not immutable Platonic ideas. I would say this guy could be part of the thing. But the question is, who could you put there? And it could be anybody from any walk of life. Could be physics, could be math, could be literature, could be anything. So if any of you have any idea, let me know. Okay. I didn't want to kill questions. Dashun and Larry.
So the second but last slides, you mentioned the limits of AI, and bound by its frame. You know, we think quite a bit these days on sort of what is the limits of AI, and I actually wanted to get your take on this because I keep wondering about whether AI is bounded by its frame or is bounded by human cognitive limits. I think I'm gonna give you a more.
The attitude that you can take is the truth is in the data and everything that is out there.
Right.
But the truth is that I don't think that that's how you could have a stumble on some of these big revolutions, because the question that could, let's say that you have AI prior to Darwin. What question could you have asked to come with a theory of evolution? You have to step outside the framework for the time being, and I'm saying yet, okay, is that seems to be, I hope this is an optimistic point of view, that seems to be at the moment outside the possibilities. Because the truth is, if you ask what's the most amazing thing that AI has ever done so far, there's lots of work, okay? Tons of work, great work, your work. But you ask, tell me what's the most amazing thing that AI has done? I mean, the most ridiculous answer that I have heard is, oh, wow, move 37 in Go. That's nothing. Or protein folding, that's fine, but it's not like solving the Riemann conjecture, for example, or something that has been pending for 100 years and suddenly you say, wow, I solved it. So the idea is that knowledge is in the existing data. And from there, you can draw tons of things. But as I try to explain with the example of origami, the things can be in front of your eyes and not being able to draw inferences. So I have no idea what was the story of someone in, I kind of have been told, let's say that someone from biology walks into a presentation by mistake of someone talking about materials and tensegrity, and then you realize, wow, now that I see this, I see biology has been doing something of this. But that's hard to put in form of a question.
Can I clarify? I just want to talk about this a little bit more. So
we can talk more separately.
the move 37, I think, is profound in the following sense, which is it generated a new idea that humans didn't know. And then there's this PNAS paper that then subsequently showed that the world champions then start to adopt the AlphaFold strategies, because now there's a human AI co-evolution. Now, my point is, if I were the AI,
Yeah.
I think it's reasonable for me to say, wait, didn't I already tell you? These strategies were already in my embedding space. So in other words, all these new things, quote unquote, the human expert have learned now, AI already knew it. And so that's my question on whether.
In the history of ideas of the world, that's really small.
That's an example. That's an example,
yeah,
right?
I mean, you of course, there could be many things, simple things. I mean, it's a restricted universe go, okay, in the same way that cellular automata is, and we still do not know all the things that it can do. But I do not yet see the example that if people were tomorrow saying, you know what, we discovered how to stabilize fusion. Wow, I will say that's amazing. People have been thinking about this, cannot do it, they have done it. AI can do so many things, so many things, and can increase our ability to do so much more that there is no need to exaggerate and claim more than it can do. I think you lose ground. I don't mean you. I mean the Altmans and the Thiels, and because what it can do is amazing, but it's nothing yet as solving, I don't know, the Riemann conjecture, for example. So, or claiming general intelligence. The truth is, robotics, AI, all of those things can do amazing things that none of us can do, but they cannot do things that a 5-year-old can do. Yeah. Larry.
So I really I liked your point about questions, obviously, as the key kind of thing to go. I mean, I think that there is a theory of questions. We often think about, am I thinking about this question at the right level? Should I be asking a more specific question or a more general question? But I guess I want to come back to when you even become bothered enough to ask a question, because you made this point about a number of times about being bothered by something that everybody else takes for granted. Or so, like, just to take an example of the cubism thing, you know, I'm not a historian of art, and so this is my potted theory of the history of art. But you know, at some point, photography raised a problem for the visual arts and painting,
Yeah.
that, you know, the veridical reproduction of the world was no longer really the right goal. But at what point did somebody say, oh my gosh, photography is causing a problem, now we should be doing something else? I mean, how do you even get to something to ask a question like that? I guess that's the point.
Let me answer with something that you told me before. It doesn't have to be questions alone. Could be some epistemology coming with a framework. You said, by the way, I imagine this knowledge sits in here, but these parts are incomplete. Let's go and find them. The example of the periodic table is the one that you gave, okay? So I wouldn't say that's a question, but it's very hard to come up with, you can ask questions like, tell me how to classify these things, okay? But I do not know if that's how the periodic table would have emerged, okay? It's at a higher level. And there are lots of people, and you send me some papers on this, that have explored that angle. What I'm saying in here, if you want to extract one thing, there has to be a renaissance in our ability to ask questions. Because, and with that ability, amazing things can happen, for example, in research. But you have to, AI is as good as the questions that you ask. Anything?
the curiosity that drives someone to ask a question. Could you imagine it's possible to somehow instill curiosity in AI systems, or is there some fundamental limit there?
I don't know. I would say that curiosity, I could teach all of you how to be more creative, for example. I think so. But it's very hard to teach someone unless how to be curious. I guess for some audiences, like, I don't know, MBA types, if you say, you know, curiosity is good for your career, to be curious, you need to follow this script, okay? You can follow that, okay? But the baseline ability to question things, or when you see something, asking how this could be done differently, that's a tough one. I think some of these things probably can be inserted into some AI things. I do not know how.
Okay, I think that's a good stopping point. Let's all thank Julio again for this really interesting seminar. And thank you, Julio, for coming.
Thank you.